Hello friends, subscribers and new viewers of this channel. In this tutorial I will teach you how to properly install Linux Ubuntu and ROS2 Jazzy Jalisco on Raspberry Pi. Over here you can see my Raspberry Pi Model 4 with an external solid-state drive attached to it in order to improve the performance. You can see the fan and I can close this case. This fan is installed and this case in order to improve the cooling. In the background, you can see the computer screen attached to my Raspberry Pi 4 by using this micro HDMI cable. Raspberry Pi is running Linux Ubuntu 24.04, and on top of Linux Ubuntu, Raspberry Pi is also running ROS2 Jazzy Jalisco. Over here, as a demonstration, I'm running two nodes. The node that you can see over here, that is in this terminal, is the publisher node. This node publishes a message with an increased string. Then I have a receiver node, or the subscriber node, that receives this message through an appropriate topic and that prints this message in this terminal. This is a proof of principle for running ROS2 Jazzy Jalisco on Linux Ubuntu. In this tutorial, I will teach you, number 1, how to properly install and configure Linux Ubuntu on Raspberry Pi 4, and the same procedure applies to Raspberry Pi 5. In fact, Raspberry Pi 5 is even faster than Raspberry Pi 4 and the performance will be even better. Number 2, how to configure and improve the performance of Linux Ubuntu such that you can run ROS2. Number 3, how to install ROS2 Jazzy Jalisco from scratch. And number 4, how to run this example. But before we start with explanations, first we will provide a summary and important notes. The first step is to create a Linux Ubuntu installer by creating a bootable solid-state drive, which is often abbreviated as SSD, or a micro SD card. In this tutorial, we will be using a solid-state drive. Over here, you can see a photograph of my solid-state drive. It's produced by Buffalo and it has a capacity of 1000 gigabyte. The main motivation for using an external SSD drive is to improve the read and write speed of Raspberry Pi. We have noticed that an SSD drive is at least 10 times faster than a micro SD card. This speed will become visible during read and write extensive tasks such as saving or loading large files or installing and building large projects. If you do not need to perform fast read or write disk operations, then you can also use a micro SD card. That is, everything explained in this video tutorial applies to micro SD card shown over here. You can, for example, use a 32 gigabyte, 64 gigabyte or 128 gigabyte micro SD card. However, the performance might be slightly deteriorated. Then, in this tutorial, we will explain how to install Ubuntu 24.04. The motivation for installing Ubuntu 24.04 is that we want to install ROS2 Jazzy Jalisco. Namely, Jazzy Jalisco requires Linux Ubuntu 24.04. However, everything explained in this tutorial applies to any other supported Ubuntu distribution and to any other ROS2 version such as Ubuntu 22.04 and ROS2 Humble. Finally, we use Raspberry Pi 4 with 4 GB RAM. However, you can also use any other version of Raspberry Pi 4 which has at least 4 GB RAM or Raspberry Pi 5. Raspberry Pi 5 is even faster than Raspberry Pi 4 and consequently Linux Ubuntu and ROS2 Jazzy Jalisco will run even better and faster on Raspberry Pi 5. Then, after the first step is completed, we will boot the Raspberry Pi by using the created bootable medium from step 1 and we will install the Ubuntu Linux desktop and configure the system. This is a very easy step that is largely performed automatically by the Linux Ubuntu graphical installer. You just need to set your username and password and set the time zone as well as the connection to your Wi-Fi or Ethernet network. Then we will optimize the performance in order to improve the speed. We will overclock the Raspberry Pi CPU and GPU. You can skip this step in the first iteration, and you don't even need to perform it if you're satisfied with the speed of Linux Ubuntu on your version of Raspberry Pi 4. However, maybe if you're using Raspberry Pi 5, you don't even need to overclock, or you can even overclock to boost additionally the performance. That is, my suggestion is try to install Linux Ubuntu and ROS2 without overclocking, and then verify the performance of ROS2. If it's too slow and if Linux Ubuntu is too slow, then overclock. And I will explain overclocking process later on in this video tutorial. Finally, we will explain how to install ROS2 Jazzy Jalisco on Raspberry Pi. And we will explain how to test the installation by running the Hello World program of ROS2 World. That is, we explain how to run the talker listener example. Note that ROS2 Jazzy Jalisco is the newest version of ROS2 and it's expected to be supported at least until 2029. Consequently, if you're new to ROS, it's a good idea to learn ROS2 Jazzy Jalisco. And here's a very important disclaimer. We don't take any responsibility if, after overclocking, the system becomes unstable or crashes. In our case, the system remains stable after overclocking. We have a heatsink and a cooling fan attached to our Raspberry Pi that keeps the temperature constant. However, it might happen that if Raspberry Pi is not properly cooled, the overclocking process might overheat the processors and create irreparable damage. We don't take any responsibility for this or if your system crashes after overclocking. The crash of the system can easily be repaired by reverting the settings. However, if your CPU or GPU overheats, then the damage is permanent and you most likely need to throw your Raspberry Pi. Okay, let's start with explanations. The first step is to create a bootable solid-state drive or micro SD card. For that purpose, you need to go to this website and don't be confused if you see this. It's written, your Raspberry Pi needs an operating system to work. That's it. Raspberry Pi OS. So they suggest you to install Raspberry Pi operating system. However, we are not going to do that. Instead, we are going to install Linux Ubuntu. Otherwise, if you install this operating system, ROS2 will not work. Now, scroll down and over here, we need to download and install Raspberry Pi Imager. This program will enable us to create a bootable solid-state drive or microSD. Consequently, click here, Download for Windows, if you're on the Windows system, and save it. On the other hand, if you're on Linux Ubuntu or macOS, you can choose your version. Next, go to the Downloads folder and double-click on the downloaded file to start the program and click on Install, and this will install the Imager. It will take maybe several seconds. And let's finish, and Imager will automatically run. If it doesn't run, click here and search for Imager. And here it is. You can simply click here and this window will appear. Okay, over here we need to make the selection. First of all, let's choose the device. In my case, I need to choose Raspberry Pi 4. Then we need to choose the operating system. Over here you can see that the default operating system is Raspberry Pi OS. We are not going to do that, so scroll down, click here on Other General Purpose Operating Systems, and over here click on Ubuntu and select this version of Ubuntu. That is 24.04. Again, we need to select this version of Ubuntu since we need to install ROS2 Jazzy Jalisco, and ROS2 Jazzy Jalisco requires this version of Linux Ubuntu. Then click here, then click on Check Storage, and over here you need to select your solid-state drive. You can see over here SanDisk Extreme with 1000 gigabyte. However, at the beginning of this tutorial, I explained that I will install on another one that is on the Buffalo one. However, you can also use any other solid state drive, and you can even use this one. And once you do that, you need to click on next, and what will happen then, the disk will be formatted and a bootable version of Linux Ubuntu will be installed, and the installer of Linux Ubuntu will be installed. And that's it. Then, after you have created a bootable disk, you need to perform the steps explained in the sequel. We will not film these steps since it is challenging to film the screen during the installation process. The steps are actually straightforward. Number 1. Make sure that the Raspberry Pi is turned off. Plug in the bootable SSD drive or the microSD card to the Raspberry Pi. In the case of USB SSD, you need to plug it in to the USB 3.0 port, since this port is much faster than the USB 2.0 port. Then, turn on the Raspberry Pi and wait for some time until the Linux Ubuntu installer starts. Number 3. After the installer starts, you will be asked to enter your time zone, set up the network connection, that is, you need to enter username and password to your internet connection and number, and in addition you need to configure the Linux username and password. Then, in step number 4, after you complete the step number 3, the installer will automatically install and configure Linux Ubuntu on Raspberry Pi. Then, the installer will automatically restart Raspberry Pi, and you will be able to log in into your Linux Ubuntu session with your username and password that you created during the installation process. Once the automatic installation procedure is completed and once you log in, you will see this beautiful screen and you can start using Linux Ubuntu on your Raspberry Pi. However, my suggestion is to try to optimize the performance. This has to be done in the case of Raspberry Pi 4, since Raspberry Pi 4 is a computer with limited resources. I didn't test the installation on Raspberry Pi 5, however I believe that Raspberry Pi 5 is much faster and you will not even need to perform the optimization steps. Okay, the first step is to install the appropriate web browser. And you might ask me, well, why do I need to install a web browser since over here I have Firefox, and over here you can use Firefox, you can enter any address, you can do whatever you want. However, my experience is that Firefox doesn't block ads and some websites are slow. Furthermore, it occupies a lot of RAM memory and you might not be able to use some other programs. An alternative web browser is actually Brave. In my opinion, Brave is much better. And it also blocks ads and it also is much faster and it doesn't consume so much memory. Okay, to install Brave, you need to basically go to this website, and for that purpose you can use Firefox, and you need to execute these commands. This command, this command, this command, this command, this command in your web browser. I'm not going to do that in this video tutorial, however, you should do that. If you're using Raspberry Pi 4, you might consider to increase the speed of your CPU and GPU by overclocking. This will increase the speed of execution of some programs, as well as installation of ROS2 and installation and running of ROS2 nodes. However, as explained at the beginning of this tutorial, inappropriate overclocking can create instability or, in the extreme case, burn your CPU or GPU. Consequently, it is important to have proper cooling system. Also, if you're using Raspberry Pi 5, you might not even need to overclock, since Raspberry Pi 5 is faster than Raspberry Pi 4. Or you might try to overclock Raspberry Pi 5 to further improve the performance. Again, I don't take any responsibility if after overclocking your Raspberry Pi is not stable or if your CPU or GPU burns. The settings that I implemented and that I tested work on my Raspberry Pi 4. However, it doesn't mean that they will perfectly work in your case. Maybe you have a worse cooling system, or maybe some other things are different. Consequently, be very careful when you overclock. And here are some important facts about Raspberry Pi 4 that you should keep in mind when overclocking. First of all, the standard CPU frequency of Raspberry Pi 4 is 1500 MHz. Now, online it is reported that Raspberry Pi 4 remains stable up to 1950 MHz, and instabilities have been reported above this frequency. Then, the standard GPU frequency of Raspberry Pi 4 is 500 MHz. We have noticed that it is okay to push this to 750 MHz. Before you overclock, you have to make sure that you have a fan attached to the Raspberry Pi 4 and that the heat sinks are attached to the CPU and GPU. Also, you have to make sure that the proper power supply is available and that is rated for at least 3.5 amps. Overclocking will increase the current consumption. So let's learn how to overclock Raspberry Pi 4. And again, you're doing this at your own hand. And maybe it would be even better to try to install and use ROS2 without overclocking. Before I explain how to overclock Raspberry Pi 4, I need to mention the following. At the same time, while typing the commands, I'm also filming this video on my Raspberry Pi 4, and consequently my Raspberry Pi 4 is significantly slower. This is due to the fact that the software for recording this video and for recording the sound from my Microsoft consumes a lot of CPU power. In your case, you will be able to smoothly use Raspberry Pi 4. So be patient and have a consideration for me, and also keep in mind that my voice might sometimes be broken due to the fact that CPU consumption reaches 100%. Okay, the first step is to start a terminal. To do that, click over here and search for terminal. And click over here to start the terminal. Now, before you install anything, you need to run these two commands, sudo apt update and sudo apt upgrade. These are very important commands that will make sure that your system and all the packages are up to date. So let's execute these commands. And over here you need to be patient, since this might take a while, especially if you're executing these commands for the first time. It might even take 10 minutes to update and upgrade everything. So let's start. Press enter. Okay, now we are ready to overclock our Raspberry Pi 4. To do that, we need to open the configuration file. To open the configuration file, we need to execute this command. This command will start the nano editor, and it will enable us to edit this file in boot and firmware folders. So let's scroll all the way down, and over here you need to enter these lines. Now, you probably don't have these lines since this is the first time you're editing this file. However, I tested overclocking several times and I have these lines. So type these lines. This line will increase the voltage. It's not going to set the voltage to 6 volts, however on some scale it will increase the voltage such that more voltage is provided to the processors, and this is necessary since more power will be consumed. Then we need to set the frequency. Over here I'm setting the frequency to 2000 Hz. The original frequency of Raspberry Pi 4 is 1500. To repeat, the default CPU frequency of Raspberry Pi 4 is 1500 Hz, and over here I'm overclocking the CPU frequency to 2000. In my case, instabilities didn't occur. However, I noticed that if I go over this number, instabilities will occur. So maybe the safest option for you is to put here, for example, is to put here, for example, 1800. Okay, so this might be on the safe side. or you can experiment and you might try to increase this. Let me return this to 2000 such that I keep everything as it is. And over here I'm overclocking the GPU frequency. I'm setting the GPU frequency to 750. As I mentioned previously, the default GPU frequency is 500. And you might also want to be on the safe side, so you might decrease this to 650 or to even 700. After we made these changes, press Ctrl O to save the file and press Enter, or you can press Ctrl S to save the file. Then you need to press Ctrl X to exit, and you're back in the command prompt. Next, you need to restart your system. After you restart your system, open a new terminal and let's test overclocking. To do that, we need to execute this command. This command will retrieve and it will print the CPU frequency with a period of 1 second. And let's see what happens. Over here you can see my CPU frequency. It's currently 2000 megahertz and it's being updated every 1 second. You can see that currently I'm running with the max CPU frequency. This is because I'm recording this video and my recording software consumes almost all of CPU. And that's it. Now we can proceed with ROS2 installation. Okay, let's start with explanations. First of all, open your web browser and go to Google and search for ROS2 Jazzy. Then click over here and an official ROS2 Jazzy web page will open. Then scroll down and click on installation. Or you can immediately go to this web page. Over here you have several options. You have installation by using binary packages, you have installation by building from source, and you also have some other installation options such as, for example, using Docker. In this video tutorial we will be using binary packages, and I suggest to everyone who is completely new to ROS or even to advanced users to use binary packages. So let's click over here on Debian packages, which is a recommended option, and over here are the installation instructions. We need to carefully perform all the installation steps. Now, the next step is to open a terminal. I have already opened a terminal. However, if you don't know how to open a terminal, you need to click over here and then you need to search for terminal, and then you need to click on the terminal and terminal will be opened. However, to save time, I will start writing commands. The first step is to set locale, and you need to execute a set of the commands given over here. Let me zoom in such that you can see what's happening over here. Namely, you need to have UTF-8 installed on your system and properly configured. I think I already have it, and you have probably already have it, because if you type locale, you will see that over here it's UTF-8. However, let's in any case just execute these commands to make sure that there are no any omissions. So click here on locale as I did, then click over here and execute this command. Now, over here it might be a little bit slow since at the same time I'm actually recording this video and executing commands on my Raspberry Pi, and if you hear my voice is breaking, this is due to the fact that I'm using most of the Raspberry Pi CPU. So please excuse me for that. Next, let's execute this command. Then let's execute this third command. Then let's execute this command. And finally, let's type locale to make sure that the settings are okay. We can see that we have UTF-8. The next step is to enable required repositories. We need to sudo apt installed software properties common, so let's execute this. And let's be patient. And over here, let's add repository universe. Let's press enter and let's be patient. Next, we need to add the ROS2 GPG key. To do that, we first need to run this command, sudo apt update, and we need to install curl. And this might take a while. And let's be patient. Next, we need to execute this command. And then we need to add the repository to our source list. Consequently, we need to execute this command. Over here, I suggest you to install the development tools. This might look optional, however, it's not. It's better to install it since you might use it. Then over here you need to press yes and enter, and again you need to be patient. This might take a while. The next step is to install ROS2. Again, let's run sudo apt update. And then let's execute sudo apt upgrade. This is always suggested. And now again, this might take a while. Let's see calculation, and let's press yes over here, and let's be patient. Let's see how long will it take. This is not going to take a long time, since I'm regularly upgrading my system. So let's see. And finally, to install ROS2 Jazzy Jalisco, we need to execute this command. And now this will take a while. You can see what are the suggested packages over here, and let's press yes over here. You can see that around 1.2 or 3 gigabyte of our space will be consumed. Since we are using an SSD, this process will actually be very fast compared to using a micro SD card. And after approximately 10 minutes, ROS2 will be installed. The next step is to verify the installation. To verify the installation, we need to run the Talker listener nodes. To run the Talker node, open a new terminal and then source the environment. To source the environment, you need to execute this command. And after executing this command, we need to run the Talker node. To run the Talker node, we need to execute this command. This command will start the Talker node, and the Talker node will send a string with an increasing number. The number will be updated every second. And this message will be sent to an appropriate topic, and on the other side, we will run the listener node. So let's run this command. After running the Talker node, you will see this message, publishing hello world 44, 45, 46, etc. That is, we are sending this string to an appropriate topic. On the other side, we need to run the listener node. To run the listener node, open a new terminal, and over here in the new terminal, you need to source the environment again. That is, every time you want to run ROS2, you need to source the environment. And the next, we need to run the listener node. To run the listener node, we need to execute this command. And over here you can see that we have received the message and this string is printed out. I heard hello world 107, 108, 110, etc. And over here you can see what the publisher node doing, and in real time the subscriber node is receiving the messages. And that's it.